Welcome back, guys. So this is problem 76 of our book, and here the statement is machine makes error in a certain operation with probability p. Okay, so the probability of error is p. There are two types of errors. The fraction of errors that are type 1 is alpha. Okay, so type 1 error, and we have type 2 errors, and the fraction of the type 1 error is alpha, while the fraction of the type 2 error is 1 minus alpha. So before proceeding to the other parts of this question, let me first write the given data, okay, to formulate the strategy for solving this question. So here we have probability of error, that would be p. Okay, and from this statement we can very clearly infer that the probability of no error would be how much? That would be 1 minus p. Okay, similarly for type 1 type of data, we have the fraction of it equal to alpha. Okay, for type 1 error we have the fraction of it alpha, and for type 2 we have 1 minus alpha. So in order to find the probability of it, we have to multiply this fraction with the total probability, and we will get the probability of that type of error. So for type 1 error, what we have to do, I have to multiply alpha with p probability, and for type 2 I have to multiply the fraction of it, which is 1 minus alpha, with the probability of error. Okay, so this is all the data which we had in the statement. So now let us proceed towards the solution of our question. So now for it, let me move down here. So we have to find out that what is the probability of k errors in an operation. Okay, so this is the first statement or first part of our question. So here we have A, and here we have to find out the probability of k errors in n operations. So this is clearly the problem of the word binomial probability law, and here the formula of it would be n choose k. Okay, from n we have to find the probability of k errors, and the probability of the error is how much? That is p. So the power of it will be k, and similarly the probability of no error is 1 minus p, and the power of it will be n minus k, and this is what? This is because of the binomial probability law. Okay, what is part B? So in part B, what is the probability of k1 type 1 errors in n operations? This is part B here. So for solving it, let me move down further. Okay, so this is part B, and we have to find the probability of k1 errors in n operations. Okay, so here we have the total number of operations equal to n, while the trials we have is k1. Okay, and the probability of k1 type error is here. So I have to write here alpha p, and with it I have to write this k1, and the probability that we don't have the type 1 error, that would be 1 minus alpha p, and here we will have n minus k1. Okay, similarly now for part C, we have to find out what is the probability that k2 type 2 errors in an operation. Okay, so here we have to, let me move down further. Okay, so in C I will have to find out that what is the probability of k2 type 2 errors in n operations. Okay, so here it would be what? N k2. Okay, and the probability of type 2, so this is this one, the probability of it is given, and it would be 1 minus alpha p. Okay, and the power of it is k2, and the probability that it is not the type 2 error, that would be 1 minus alpha p. Okay, and the power it will have would be n minus k2. So this is the solution of part C. Similarly in part D, we have to find out what is the joint probability of k1, okay, k2 type 1 and type 2 errors respectively in n operations. So here in last part of it, what we have to do, we have to find the joint probability of our problem. So here it would be the probability of k1 k2 in n operations. Okay, we have to find the probability of k1, k2 errors. So there we have two categories which are k1, k2, okay, and the third category here as well. These are two categories of the error, okay, and also we have third category that we will have no error, okay, and we also note the probability of the no error, and that is 1 minus p, okay. So now writing all these term here and finding the probability here, and the problem here will become the problem of the multinomial probability. Okay, so for the multinomial probability, we have the total number of operations n, and taking the n factorial, the first problem we have is this k1, so writing the k1 factorial. Similarly, k2 types, so k2 factorial, and I have another type of the things which are of no error, so it would be k1, let me write it here, k1 and k2, these two are the errors, okay. So the terms which are left will be of no error, and how to find it? So why we have to subtract these terms from the n, so from it I will get n minus k1 plus k2, okay. So these will be the terms with no error, okay. So here similarly writing here the n minus k1 plus k2 and the factorial of it, okay. So this is here. After it we have to multiply the probability of all these terms. So the probability of k1 is how much? That is alpha p, and writing the power of it k1. Similarly, the probability of k2 is 1 minus alpha with p, and the power of it is k2. And similarly, the probability of no error, as we previously found out, is how much? Let me write it here. That would be 1 minus p, and the power of it will be n minus k1 plus k2, okay. So this will be the power of it. So this is the solution which we in which we have to find out the joint probabilities of k1 and k2 terms in our n number of trials, okay. So that's it for today, in which we have found out all the terms related to our question 76. And if you have any question, you can ask me in the comment box. I will see you with some more questions in our upcoming video. Till then, take care of yourself, and I will see you soon.